Good evening, everyone. Welcome to the IntelliHack NextGen Workshop 2, organized by the IEEE Computer Society Student Branch Chapter of UCSC. I'm Bhagya Semage, your host for today's session. We are thrilled to have you all join us for this exciting workshop. Before we dive into today's topic, let's take a moment to introduce our esteemed speaker. We have with us Mr. Sahan Dissanayaka, a research assistant at the COTS Lab, UCSC. Mr. Dissanayaka specializes in cutting-edge technologies, and today he will guide us through the fascinating world of developing LLM applications with LangChain and Hugging Face. Mr. Dissanayaka has a remarkable background in research and development. His insights promise to be both enlightening and practical for all of us here today. Throughout the session, he will be here to provide guidance, answer your questions, and share practical insights from his experiences. Whether you are just a beginner or looking to deepen your understanding, this is the perfect opportunity to learn from the best. I encourage each of you to actively participate, ask questions, and make the most of this interactive learning experience. Additionally, the Padlet link will be available in the chat box where you can drop your questions. So without much further ado, let me hand over the session to Mr. Sahan Dissanayaka. Over to you.
Okay, thank you, Bhagya. And thanks for the nice explanation and the introduction. So welcome, everybody. So as Bhagya said, I'm Sahan Dissanayaka, currently working as a research assistant at UCSC under COTS Lab. And I'm hoping to do my PhD this year and hoping to move to US. So, and thanks for inviting me, IntelliHack organizing team, and thanks for joining for this session. And I believe you take something out of this session at the end of this session. So without further ado, let's jump off to the session. Let me start my screen sharing. Okay. Hope you guys can see the screen. So, okay. Okay. So today's topic is develop LLM applications with LangChain and Hugging Face. So before moving to LangChain and Hugging Face, let's clear some background things like the ground things, and there are a lot of things that we have to keep in our mind before going to LangChain and Hugging Face. So as you may all know, like the generative AI has come a long way. So now we are talking and witnessing a lot of creative outputs from Gen AI models. For an example, you might have used ChatGPT in your everyday tasks. So it's just a one model, but there are a lot of other generative models like Midjourney for image generations and Whisper for audio generation. There are a lot of other models. We are just utilizing the text generation models nowadays, but there are a lot of other Gen AI models. But that is the core reason that why I accept the invitation of IntelliHack to talk about LLMs in like the context of how to properly develop them, having a proper foundational knowledge. So I heard that there was a one session beforehand, and I hope you have some sort of knowledge about LLMs. But don't worry, I cover some of the things. So I just jump off through those sections. But if you have any questions, you can ask in the chat. I'm happy to answer those questions. So and the other thing is, I want these sessions to be interactive and not one of a kind of lecture you are attending every day. So please interact with me. I'll ask few questions here and there, so you guys can engage with me. So I believe you can access the chat also. So whatever the ways you can engage with me, and yeah. So as I highlighted here, so first we talk about the crucial two aspects of LLMs. The first one is the formal introduction to LLMs. So in here, we are talking about not only the enterprise aspects of the LLMs, like we are developing LLMs, and also the research aspects. So there are few things that we have to keep in mind. So I prepared two sections for that. First one is the formal intro to LLMs, and second one is LLM development lifecycle. So those two sections, I will elaborate the necessity of Hugging Face and LangChain, sort of tools and why we need those tools to do LLM development. And at last, we'll see some demonstrations and put forth those ideas into practice. And maybe like we can explore more things about LLMs, and I'll show you what are the future things that we can explore, because it's very hard to cover everything in LLMs in one session. So there are a lot of other research areas and things that we have to explore. So I'll explain you what are the pros and also cons of LLMs. And here I asked the first question actually. Can you see a picture of three people in this slide? So do you guys know about those people? So some people may seen these guys, but didn't actually know who are they. So you can guess. I think those are very famous people right now. I mean, for me, it's like living legends in the world for AI. So you guys can try. Okay. I'll go ahead with those three people, and these people known it as the godfathers of AI. So this is the one of the main reasons AI has evolved this far, especially in the domains of deep learning and generative AI. And these three people have won the Turing Award in 2018, if I'm not mistaken. So the Joshua Bengio, the person in the left-hand side, and in the middle, Jeffrey Hinton, and in the right, the young LeCon. So these three people actually work. The first person is work for Apple. Still, he's working for Apple. And Hinton is, I think he recently got out from Google. And Yang, he's still working for Meta. Actually, for these, one of the most popular IT firms in the world, Apple and Google and Meta. So in terms of LLMs. So it's very important keeping in mind these people. And yeah, let's go ahead with for the rest of the slides. And yeah, so why I put this slide, because I just want to like make your minds clear about the impact that LLMs made to the current context of the world. So because even a Montessori child know what is ChatGPT right now. So why actually a tool kind of like ChatGPT has came so far, like because everybody in the world right now know about ChatGPT. Even like a small sentence, they know what is ChatGPT. It's a very rare case actually, and so there are a lot of things. The LLMs and actually the ChatGPT and other tools have impacted for the whole world. So there are these are few facts actually. As you know, this is the focal point of AI technology. And guys, give me 1 second. It's raining here, so I need to close up my windows and come back. Give me a second. Okay, so yeah. So there are a few things that we have to keep in mind, and just I want to highlight why LLMs are in the pinnacle of the AI technology right now. So in not in terms of the numbers, like in terms of enterprise, a lot of companies are now trying to move with LLMs. So in the numbers, like the media exposure of LLMs increased by 30-fold in 2023. So it's even for a celebrity, don't get that sort of a number, but LLM does that. So kind of like a celebrity right now for the whole world, LLM. And Microsoft, I think, if I'm not mistaken, in 2022 has invested $10 billion in OpenAI, and now it's a part of Microsoft, and they invested a lot in generative AI and LLMs to. I think you guys have explored newbie AI. It's powered with LLMs and OpenAI. So a lot of investments are happening through LLMs. And lastly, like approximately 562 entities have declared their active engagement with LLMs, showing a 10% monthly growth. For a month, if it is 10%, and yearly it's like 120. So it's a big number. So the impact is very large, and it's very important as IT undergraduates to know about LLMs, because you guys may have going to industry maybe this year, maybe next year. So it's very crucial for you to know about LLMs. So that's the importance of this area, and I'm glad IntelliHack and the organizing team come up with this sort of an area to organize a hackathon and everything. So it's a great initiative. And yeah. So LLMs are not very new to the world. So it started from 2017 with the paper of Transformer. Attention is all you need. You might have heard about the research paper. And then after Google built their first transformer model for Google Translator, I think the model name is T5. And then after 2020, the huge step, which is a huge step for the LLMs, is ChatGPT, or we call it as GPT model. So they build their own platform for the whole public to try out their model. And then it's came a revolution, and everybody use ChatGPT to do their everyday email writings and whatever the task that they want to do from GPT. And then after, every tech company and tech competitor put forth their LLMs to stay in the game. But now in 2024, we have around 6,500 LLM models in the world. You might can't believe it. So that's the truth. So we have like thousands and thousands of LLMs right now. So along the journey, there are a lot of other models as well. This is just a snapshot. So if you want to try out, you can read this paper. So it's if you are a new or a beginner to LLMs, this is a good head start for you, because you can learn a lot of things through this paper. It's kind of a review paper, so you can get to know a lot of things about LLMs. Okay, so in this diagram, I just want to focus where it plays in the phenomena of AI. So it's a marriage between deep learning and NLP. So why it's under deep learning? Because all the deep learning architectures have involved to develop LLMs, mostly transformers. In future, there can be new architectures. So mostly it should come under deep learning. Because it's very hard to implement a large language model using machine learning algorithms. So I don't believe it's there can be a necessity, but there can be a possibility of coming up a new architecture with machine learning algorithms, but it's very hard. And actually, still, LLMs are using to simplify the NLP tasks. So it comes under NLP. So why call it as large actually? Because it's a very huge network which has a lot of training parameters, and also it requires a lot of data. It's not like 1 gigabyte or 2 gigabytes of data. It needs trillions and trillions of data. So we are calling about a huge database. So it's very hard to replicate that sort of a database from an individual perspective. So That's why we call it as large. Because you might not believe it, because the Google's BERT model is it trains with 10 years of Google search results. So 10 years of Google results means it's, I think it's a huge number of data points are there. Okay, so why LLMs are so versatile? So because it can handle not just text generation, it can do text summarization, text translation, question answering, syntax checking, text reasoning. I think every day you guys are like prompting these things through ChatGPT. So you are not just generating new poems or new text. You also use that to summarize your text or do like a Grammarly sort of a tool. Sometimes you are just putting that sentence to check your grammar. And sometimes you are like talking with like a question answering bot, like you are asking questions from ChatGPT. And sometimes you are just asking text reasoning. So what's the secret behind all of this? So how a AI model come this far? So the secret is the LLM architecture, which is the transformer architecture. So as we speak, the secret is transformer architecture, which is the outcome of Google research in 2017. Why this model is so efficient and optimal to do language tasks? Because it's not just like, because I think by 2017, until Google released their paper of transformer, most of the language tasks were delivered by recurrent neural networks. So up until that point, a lot of researchers, also practitioners, using RNNs to do language sort of problems. But this is not an RNN architecture. But it can capture long-range dependencies in text because it uses attention mechanisms and also positional encoding. So those two are the two techniques that they are using to improve the transformer architecture in relatively to RNNs. And it uses tokens. Tokens, they are handling simultaneously. We call it as multi-head attention. So we can like input a large text corpus to the model and then get the outputs. So it's very accurate and it's very efficient. So that's why transformer is very popular. And in terms of architecture, it's a very elegant architecture. But it's very simple actually. It has only two components, namely the encoder and the decoder. So thus far, there are three variations of the transformer architecture. Like we can do some tweaks and create a variations of transformer architecture. One is encoder decoder. We are using both encoder part and also the decoder part. And we can only use the encoder part. And sometimes we can only use the decoder part. So those three are the variations. I'll tell you why researchers are moved with those three variations. And actually, there are architectural pros and cons also. So if we go ahead with encoder only LLM, not LLM, actually the transformer, it's good at doing the language understanding. The models like BERT are good at language understanding. And if we go with only the decoder part, it's very good at language generation, not doing the language understanding, good at doing the generation part, which is the Gen AI part. So that's why GPT is ahead of the game compared to BERT and Llama. And Llama is also a very good model, but compared to GPT, it's still not in a good state. But still, GPT can be considered as the best model in the world for language generation. So there are also models like encoder decoder. So it's a joint focus on to do language understanding and also language generation. So T5 and BART are a good example for that. Both are Google research outputs. So if you like interested on like what is the architectural aspects of transformer, you can read this paper. The attention is all you need. So if you are ML researcher, you should read this paper, and I'll encourage you to read this after the session because it's a very interesting paper. Okay, so since we know about why transformer is good at NLP? Because formally it's supposed to do both language generation and also language understanding. To be specific, these are like two sides of the coin. So language generation is not as a language understanding. So now I just highlight you the point that why and what sort of architectures it needs. You guys can answer to this question. So the next question is, so what sort of an architecture is better to do language generation? I mean in transform. So the answer is quite straightforward. So the answer is you have to go ahead with decode only model or encoder or decoder architecture because it's good at doing generation part. So if you want to do language understanding sort of an task like language translation or sort of like question answer in chatbot, so you have to go with encoder part of the transform. So yeah, if you want to do both, so you have to definitely go with encoder decoder architecture like T5. So this is the research aspect and the technical perspective of the transformer and LLMs. So it's very crucial to know about those things because otherwise it's very hard to like grow the knowledge about LLMs. We are just blindly using the tools. So it's not the right way of learning things. So that's why I just sort of like explain those things beforehand. So as we speak about architectural aspect of LLMs, let's go to the development part. So beforehand, I think you may already know about those things, the typical ML development life cycle. So it's very important, like anyway, that's even if you guys do some research, you know that after doing the research, there should be an output. So it should be a model. So in terms of like the enterprise, it should be an application. So it's an end-to-end life cycle. So we call it as ML ops in enterprise terms. So we can break it down to few sub-ventures like, so in ML ops, so we can consider the data part as data ops and model part as model ops, AI part as AI ops, and altogether the HC part. So the deployment and implementing services, we call it as the DevOps part. So that's how all the things comes under the ML ops part. So and it's very crucial to know about these things, and the phases are really important when we are doing the development part of ML applications. So the data gathering, explorative data analysis, and the design part, and then feature extraction, experimental design, modeling, and then implement whatever the microservice that you are going to implement, or maybe like by creating an API, and then deploy the model, and then after you have to maintain it, and then you have to monitor it, and you have to retrain it. So these are a lot of steps involved when doing ML ops. So yeah, so I just want to highlight that that's how the models like GPT models comes into play. It's not just training the model and put somewhere. So it's a life cycle. So we have to maintain it every day because, as you know, like every day the data set is growing in the world. So we have to retrain the data set, and because the models like LLMs can't train in a single day. It can take like months, 2 to 3 months. Okay, so because LLM development is very similar to ML development, but there are some tweaks done by researchers to make it more accurate. So as we saw in ML development lifecycle, so it has data ingestion and the preparation, because at the end of the day, it's about data, and we are finding patterns to generate new data points. And we have to do modeling and pre-training and fine-tuning. So this is somewhat special for us. So, and then model evaluation, deployment, and monitoring and maintenance. So these are the crucial steps in the LLM development lifecycle. So you can see the figure. So we have a lot of databases help for us to do the pre-training. Pre-training in the sense like we will come to that part, but pre-training, let's say it's the modeling part actually. So then after we have a foundational model, and then after we have to do some fine tuning. So fine tuning in the sense like we are adjusting that large language model for our use case. So then after that, it's a fine-tuned model. Also, it's prepared for our use case because large language model is a generalized model. So we can use that model for many use cases. But fine-tuning part like makes easy our job to do, like let's say we have only small task, but we are using a very large one. So fine-tuning is very essential in that sort of nonsense. So pre-training and fine-tuning is the special step compared to ML development lifecycle. But can you guys guess what's the problem with pre-training for us? Like the people like us, there are few problems to deal with if we go with this architecture. Because if we are going to implement a LLM from scratch, so what are the problems that we have to face if we go with this LLM development lifecycle? I'll give you guys 1 minute so you guys can give your opinions because it's very crucial to understand this point. Otherwise, yeah. Cost, yes. Which cost? Answer is correct, but be specific. Yes, computational power, that is one. Exactly. We need huge amount of training data compared to fine-tuning. So yeah, answers are quite the accurate one. That's the things I expect from you guys. So thanks for the answers. So it's very impractical to gather that sort of a large data set for individuals like us. So that's why we need some pre-trained models developed by somebody else so we can directly use. So GPT is that sort of a model that we can use directly for our applications. There are a lot more actually that implement by OpenAI. There are a lot more actually. There are models developed by Mistral. I think you might have heard about Mistral AI. So they have their own LLM, and Google have their own LLMs. Apple have their own LLMs, Meta, so and so forth. There are a lot of companies who develop LLMs by their own for their own use cases. And I worked previously for an organization, so they have their own LLMs. So kind-wise, we have a lot of LLMs, so they specifically maintain for their purposes. So that's why we need a platform like Hugging Face, because for individuals like us, it's not practical for us to implement a LLM from scratch, but we can get the essence of the models. So we can take the pre-trained LLMs. So I just moved to LLMs. So sorry, Hugging Face interface just for you to, let's say we want to use the Llama model. So if you have an account in Hugging Face, you can see how this model is implemented, what sort of data they have used. So a lot of information is there. You just have to take their model as an input. So then after you can do the rest of the architecture, like so in terms of the architecture, you can do the rest of the things. The fine-tuning part you can handle by yourself. So the pre-training part is the most hardest part in the LLM development lifecycle. So rest of the things we can actually suffer and fine-tune our own LLM for our application. So I like encourage you to go to huggingface.co and let me like drop the link in the chat. And let's see the chat. Okay. This is the link. So you just have to go to Hugging Face and just create an account and sign in. And then after you can access, like I said, there are actually this sort of models are there in Hugging Face. It's a lot. So you can use whatever the models. This is openly available for everybody. This is open source platform. And you can use, it's ready to use. You just have to write your Python code and import all of these LLMs. Okay. So that's why I mentioned the Hugging Face, the savior. So those models actually train with large corpus of, actually it can be customer chats, it can be FAQs, insurance policies. You can find a lot of models related to those specific domains. And what else? So there are chatbots, and yeah, there are a lot. So just go and see which sort of a model is suits for your application. But for this demonstration, let's go with the generally the most popular LLMs for our demonstration purposes. But there are a lot. So for an example, if you like want to build a chatbot, you can yeah, the emotion chatbot. So this is specifically designed for like recognizing emotions through a chatbot. So these sort of and specific use cases are there. Yeah, it's up to you, and it's a treasure actually for researchers and for the students who are keen in LLM. So just go and find your right one. Okay, and one more thing, you need to like create your token, like before whatever the task you are doing, you need a token, because that's how you create the link between your Python script and with Hugging Face model platform. So go to your settings and just go to access tokens. And here you can see I have my token, name it as IntelliHack. So either you can create a new token and just give a name, and it can be read. So don't put it as write, because you are not just writing your model prompts to that model. So make it as read and generate a token. Yeah. That's how you have to like create a token in Hugging Face. So the beauty of this Hugging Face, as I said, it's open source and free to use. You don't have to pay anything. And yeah, there are a lot of options. So it's a nice platform. So yeah. And then actually in Hugging Face, if you like, let's say there are a lot of flaws and there are a lot of mistakes in the model. So actually you have to fine tune a lot. So let's consider this architecture, our LLM development lifecycle architecture. So if your model is not developed properly, you have to waste a lot of your time to do the fine tuning part. So in Hugging Face, it just provides you the models. It just doesn't provide you the tools that helps you to do the fine tuning part. So that's why the LangChain is helpful to do the fine tuning, and it has a lot of tools like chains and like other the parsers, actually the parsers and indexers, chains and agents. So those tools are available in LangChain. So again, it's an open source framework for like connecting LLMs and data sources, other functionalities in a unified syntax. So it's written in Python. So and also there is a JavaScript extension also. So you can either use the Python or the JavaScript format. And it's there are other like advantages, like it's allows you to do the scalability and containerize, like modular components are there. And as I said, the chains and tools are available to optimize your LLM output. That's what you need actually to do a proper development of LLM. So that's why we need those two tools to do the LLM development. I hope you grab the semantic of Hugging Face and LangChain, because it's very important. Because the necessity of using LangChain and Hugging Face should be very much straightforward for you before going to the hands-on session. So I'll just open the thread for you guys. So if you guys have any question for me up to this point, you can raise in the chat, or I saw that organizing committee has put a forum. So the wherever you want, you guys can answer the questions. Okay, I'll just put the LangChain link also in the chat. So meanwhile, like organizing committee, if you guys like came across with questions, you guys can post in the chat for me, so I can clearly answer those questions in the meanwhile. No rush. Okay, seems like no questions. Okay, great. So let's move on to the hands-on part. Actually, this is, I think you guys have waited for the hands-on part. If you guys are boring with the technical part and the theoretical aspects of LLMs. So in the hands-on part, I just break it down to 3 sections. So in the part 1, I'll show you guys, I think I show you like there are a lot of language tasks that we can perform through LLMs. You just have explored the text generation part only, but there are a lot that we can do from LLMs. I'll show you like how to implement a question answering bot and how to implement your own Google Translator through LLMs. And there are a lot actually we can perform through LLMs. And then after we'll see the prompt strategies and how to select a proper model for your application, and what are the prompting strategies that you can use with LLMs, LangChain and Hugging Face. And as part 3, I'll show you how to give the capability of model memory and context inclusion for your LLM, like the personalization. So you can chain a lot of prompts to your LLMs and get the relevant output for your prompt. So this is the plan for the hands-on part. And I'll use Google Colab. And after the session, I'm kind of like hoping to share the Colab with you guys. But if you have the opportunity and the environment, so just do the all demonstration with me, so you guys can learn a lot. And if you have any concerns or confusions, you can directly raise in the chat. Okay. So let's go with the part 1 of the demonstration. So let's perform few language tasks. But for this demonstration, I'm not going with code generation, because it's kind of an hectic task to perform, because it requires a lot of okay, yeah, I got a question. So what is the difference between directly connecting OpenAI and LangChain and connecting Hugging Face with LangChain? Okay, yeah. So this is the reason. So that's a great question. So in LangChain, it has both open source models provided by Hugging Face and also closed source models like GPT and LAM. So those are not open source model. So in LangChain, we have the capability of accessing those models as well. So LangChain is allowing us to use both of the models. So as I explained, the Hugging Face, it's sort of an open source hub. So, but it has OpenAI models, but it allows you to create an OpenAI key. I'll show you that. So that's the difference. So even if you try with OpenAI models with Hugging Face token, it's not allowed you to do like prompting. So that's the disadvantage. And yeah, that's the difference. Hope I answered your question. We'll see you some demonstrations so you will understand, and I'll show you how to create OpenAI API keys as well in the demonstration. So yeah. Okay. So in this demonstration, we are just focusing on the text generation part only, because code generation is a bit hectic, and it will it's require a lot of data actually. Data in the sense your internet connection. It should be you should have a lot of bandwidth, and it takes a lot of time to train and prompting. So that's why I just want you give some heads up with text generation. Maybe you guys can have the exploration part in the code generation. And yeah, so let's go ahead with part one. Okay, so this is a notebook I have created, and let's start with this. And beforehand, so we need some package installation. So for the Hugging Face, we need this package, the transformers. So just have a look called transformers. So okay, so this is how you can install. So this is the documentation, the original documentation provided by Hugging Face to install the transformers. So this provides you the all set of models resides inside the Hugging Face. So either you can directly pull off the code base from Git, or either you can easily install the package from pip. So yeah, this is what you need to install. Yeah, this one. And for the LangChain and LangChain OpenAI, I'll come to the OpenAI part bit lately. So these two packages are the essential packages you need to install before like using LangChain tools or the ecosystem of LangChain. So I'll quickly go to LangChain as well. So as I explained, LangChain is a framework to do LLM development. It provides a lot of it's a versatile platform to it has a lot of tools to do the fine tuning part. To be specific, like the LLM agents, you might have heard about LLM agents. Let's say for an example, you are going to implement a tool like Codex. Have you heard about Codex? Like it's specifically designed, and okay, Devin, it's the great example. So Devin is recently there are some controversial discussions about Devin also. So it's the main focus about of Devin is to replace the software engineer as a generative agent. So it has a lot of agents. So one agent is to do the Java development. One LLM agent do the Python development, and one is to do the design pattern.
Recording in progress.
The architecture. So likewise, there are a lot of other techniques and tools we can use from LangChain to develop our LLM solution. So this is the the ecosystem. So we have LangChain Core, which has the core packages and tools that we can use, like parallelization, fallbacks, like the OS level things. And then after we have the LangChain tools like chains, agents, and retrieval strategies. Like you might have heard about RAGs. So we call it as retrieval augmented generation. So to implement RAGs, so we have retrieval strategies. So we look at some prompting strategies as well in other platforms. So to do the prompt engineering, they are providing some tools, and also LangChain providing some tools. So templates are there, LangServes and LangSmith. So these three are the main three tools that we can use from LangChain. So it's a lot. So we'll cover few of them during our session. So if you have enough time, you guys can explore into other areas, because we are just focusing on these two parts today, the prompting strategies for the chat model, and then the chat memory and history. So this is only just two techniques, but it's very vital for you guys to implement whatever the LLM solutions you are planning to do. But there are many other. So I'll show you some, and but you guys can explore the rest of the things by your own. So this is kind of a foundation that you have to build before going to other tools. Okay. So for the LangChain OpenAI, so beforehand, like after installing the LangChain OpenAI, you have to create your OpenAI API key. So this is the point that we all are facing few troubles. Let me just go to OpenAI. OpenAI API. Okay. Of course, you have to sign up with your whatever, like the both options are possible, but better if you guys can create your own account in OpenAI. I'm usually using my Windows to to sign in, because it's very easy for me to create accounts. Okay, so in OpenAI API, so you have to go to the API keys, and here you can create your API key. The same way we are doing the creation of token for the Hugging Face. In order to access OpenAI keys, you have to go to this site, and so yeah, I'll share the notebook with you guys. Let's see. Thanks for mentioning that, Mohammed. So let me share you the notebook. Okay, so in OpenAI API, so just go to API keys and just create your API key. But there is a crucial point that you have to keep in mind. Just make it as all. The restricted and read-only means there are some restricted models that you can use in OpenAI, and there are some openly available models. So just make it as permissions to all, and projects, make it as default project, and just create secret key, and it just provide you a one-time copy. So then after you can't see your key actually. So that's what it mentioned here. You won't able to view it again through your OpenAI account. So better if you can copy it somewhere and paste it. So yeah. That's about creating the project API keys inside OpenAI. But I'll tell you the problem here. So usually you have to top up your OpenAI account in order to access the models. So it's not a openly available model. So you have to pay them to access the things. So this is my account. So I have top up with $10 for my everyday task every month. Not every month actually. For like it's for me it's for 4 months. It's manageable with the $10. $10 from Sri Lanka money, it's like 3,000. So I know it's a lot. So you guys can top up whatever the amount you want. So you guys can go with $5. That's the minimum amount that you have to pay. So just spend $5 with a bunch of you guys. Maybe you guys can create a group and get $5 package from OpenAI. It's not a package actually. So you can pay whatever the amount you want, more than $5, and get the API key access, and then after you can access through the API key. So it's an investment. So you guys can learn a lot from OpenAI, this sort of implementation. So it's a future investment. So I encourage you to like get these benefits of OpenAI, and just for learning purposes. So then after you guys can implement your own LLM in future. Okay, so I hope this part is clear. So I explained both Hugging Face token creation and OpenAI token creation. And then it's important for us to do the demonstration part, especially the LangChain part without OpenAI. So we can't like do the model history part and the prompting strategy part. Okay, so hope you guys done with the package installation, and then let's jump off to the basic language tasks. So from Hugging Face, let's import the transformers pipeline function. So pipeline is it has the same semantic of like we are inputting something, and on the other end we got if we input something, on the other hand we got some output. So that's the semantic behavior of the pipeline. So let's start with text classification. So text classification, nothing but, so if we input some text, so on the other end we got let's say we have some predefined groups like negative, positive, and neutral. So the text is belongs to one of the groups. So it can be positive, it can be negative, or it can be neutral. So this implementation I done for tourist review, because as I shown you earlier, the Hugging Face models are developed for specific contexts, like for insurance policies, for FAQs, or custom reviews. So the model that I have used in Hugging Face is basically, if you use the pipeline model, it's trained on those set of data. So if I run this script, so you guys can see this is the first time I run the pipeline. So there are a few things. So I'll just explain you what's the semantic behind these 4 steps. So we are just connecting to Hugging Face, and just let's say the model is not properly download for our machine, and then it download, and then it do the tokenization, and then it gives us the output. So this is the second time I'm running the model, so it shouldn't show you that 4 steps. Let's see. Sometimes it may, because my collab session sometimes it restarts, so it should show the steps again. Okay, yeah, it's showing the steps. So you guys can see the label is positive because it's a positive review actually. So it seems correct, because you can see like the dear seller, I got impressed with the fast delivery and careful packaging of my order. So it's a positive feedback. So if I run, let's say let's do some changes. Dear seller, Okay, so I'm just changing this feedback to, okay. So you can see, so this is kind of a negative feedback, right? So dear seller, I have a bad impression with the fast delivery and careful packaging of my order. Great experience overall, thank you. So it should be neutral, right? It's not semantically correct, but it should be less than 99, right? So that sort of behavior is there for Hugging Face only because it's not accurate all the time with you. And worst customer experience. Actually, I tell you why. So this is one of the bad reviews you can get from your customers. Okay, now I'm getting a negative feedback because the other time I'm mentioning both positive and also negative. So model got confused with which input I should for which bucket I should drop this prompt. So that sort of like corner cases are there in the models, but it can easily recognize the positive path and a negative path. So it serves us the purpose for most cases, but not for the all things. As same as for the ML models, you maybe got like 92% of 93%, so it means like there is a 7% of error. So same goes with LLMs. Okay, so for the text generation, I believe you guys know about text generation. So this is kind of an prompt I use, which is the going neighborhood in Kyoto is famous for. The Kyoto means like, so this data set is trained for those customer reviews. So that's why I go with this one. And maybe you guys can, if you like go with other prompts, it may not give you accurate results. Okay, the same story like for the Hugging Face, first it's download the models and do the necessary setup before prompting, and then it show you the output. For the text generation, it might take some time because the text generation required a lot of time. So you guys can see, so the Goin neighborhood in Kyoto is famous for its huge collection of colorful gardens. So there are a bunch of information. So if I input like, what is Sri Lanka, probably it will give you garbage. Okay, so you can see. So what is Sri Lanka? There are a bunch of text. So that's the reason we have to train our LLMs with the proper data set. So I think I show you earlier this LLM, sorry, Hugging Face models are fine-tuned and pre-trained with these set of data sets, not with demographical analysis of Sri Lanka, and it doesn't know about Sri Lanka at all. So that's the reason it turns out to be garbage for us. So yeah, you guys can try a lot of things, so it will not give you a proper answer. So this is, we call it as hallucination. So it show us seems like right answer, but it's not. Okay. And text summarization, again, I'm using a default prompt provided by the model. So you guys know now why I'm using this prompt for show you the demonstration. So you can see for this text summarization model, it's the model size is 1.63 gigabyte. So make sure that you have a proper internet connection beforehand. But it doesn't mean like it taking the entire 1.6 gigabyte. It just taking the essentials of the model, and rest of the things Hugging Face Hub is managed. Yeah. Just for the demonstration purposes, I just split the string into 4 lines. And here, guys, so there are a few things that we have to keep in mind. The max length. For the text summarization, we are telling the LLMs, so what sort of an length I'm expecting from the model for the text I'm inputting. So I can put 100. So definitely it should be more than 100 initially. So you guys can see the length is less than, I'm not counting it, but it seems like less than 660. So it's a summarized version of the initial text. So you can use this software model for do the summarization. So this model I use from Facebook, but large CNN. So I'll show you the model in the Hugging Face. Okay, so this is the model. Fine-tuned on CNN Daily Mail. Okay, so the model is the BART, the transform model, which has both encode and decoder part, but the training set, the fine-tuning part actually happened with Daily Mail. So that's why we have to give them the news kind of an sense for the model. Okay. All right, I hope you guys got the point. So that's the downside of using this sort of open source model. It's not very versatile about a lot of subjects. It's just know about few things. So this is another interesting model for me, actually, the question answering bot, because we can do a lot of things using question answering bots. So you guys can implement your own agent and own assistant implementing chatbots. So this is a question answering bot. So again, I'm using this Japanese context to give them a prompt. So this is the context, the walking a bit, blah, 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 houses was a mesmerizing experience. What are the Marcia houses made of? Actually, it's made from wood. So the answer is correct. So this is the question answering format of Hugging Face. So you guys can provide the context. So context is the reason is actually the LLMs trained with a lot of data sets. By providing the context, it can filter out for which context it has to be looking for when it gives the answer. So that's why we have to provide them the context with the question. Because otherwise it will take a lot of time and the answers may not be accurate. Okay. For an example, let's say you are asking about the military. So it's a sensitive topic. Let's go to something else. So let's say you are talking about rivers. So you are asking what is the longest river in this country. So it can be many, right? It can be Sri Lanka, it can be Malaysia, it can be Australia, it can be US, it can be England. So what is the longest river, right? So in the context, you can provide the country, right? So that's why the importance of context comes into picture. So lastly, let's use the language translation models. So for this language translation model, I'm using English to Spanish sort of a model. So I'll show you the model in Hugging Face. This is Helsinki NLP. It's a very famous model to like do the Spanish conversion. It's actually developed by developing Google, if I'm not mistaken. And also it has the other way around. This is English to Spanish. That's why I name it as ENES. So it has the other way around. ESEN also, Spanish to English. Okay. So both possibilities are there. So it's very easy for us to validate the answer. So we are just converting English text to Spanish and then Spanish text to English. It should be same, right? So that's why I use both models and use and see the results actually gives us the right answer. And then let's check the other part. Okay, so I'm inputting the same text here. Okay, you can see the same text I have provided in the next script. So if I see the original text here and here, okay, so I use the word mesmerizing experience here, but in the translation I got fascinating. So it's a synonym to mesmerizing. So these sort of trade-offs are there when we do the translation, but it's quite okay. So even if you do the translation in Google, it has these sort of random instances. So yeah, I just want to highlight the trade-offs by using LLMs. At the same time, the versatility of the LLMs model. So we try out a lot of tasks. So classification, generation, summarization, question answer, and language translation. So in my slide deck, I just focus on few things in terms of the pipeline. So I just want you to know about the question answering part, which is the most common use case LLMs, because a lot of people are interested in creating chatbots for their companies using LLMs. So that's why question and answer is a kind of a vital task we can implement using LLMs and language translation. Okay, then let's jump off to the part 2, which is the prompting strategies. Okay, so in the prompting strategies, I have to give you two parts. So one is the model selection and other part is the prompting templates. So when you guys creating a LLM solution, it's very important to select the proper model for your application. So we already explored a few things why I say so. So in Hugging Face model search, you can search a domain specific models for your application, like emotion chatbots. So you might have implement a gym kind of an LLM. So there are specific bots for gym chatbots. So you guys can use those things. So they are specifically trained and fine-tuned on that sort of an context. So that's why I mentioned here fine-tuned models for more domain-specific use cases. And prompting templates. So it's very important to use that. And it's good to keep in mind. Okay. All right. So prompt templates actually. So it can be. So you are providing a lot of additional information for your bot to know before it generates you an answer. So because it maybe give you some garbage, so you are just avoiding the hallucination and by providing a lot of additional information. So that's why we need prompting templates. So let's go ahead and explore those things. Okay, so I'm using both okay, so this is my open AI API key, and I'll just have a look and see if things are in order. So usually it's a better practice to go for your access tokens and do a refresh and get the token key. Because in Hugging Face, usually they are refreshing their tokens every 24 hours. So it's better, yeah, it's refreshing every 24 hours. And this is my open OpenAI API key. So guys, don't use this key because I just it's okay. It's okay to try for your demonstration purposes. After this session, I might be drop this API key, and better if you guys can create your own key because it's not cost you a lot of money, and yeah, okay. Give me a second. I just want to change my internet connection. Seems like after importing the model, I think my data package got distracted. And yeah, okay. No, that's the actually the downside of using a Hugging Face model. You have to uh, be with a strong internet connection because it's grab a lot of data from the internet, and ultimately it's cost you in terms of data connection side as well. All right. Okay. The API part is fine. So let's go ahead with model selection part. Okay. This example I'm using first model I'm going with Hugging Face, and the second model I'm going with GPT 3.5. So you know this is an open source model. Let me show you in the Hugging Face. Okay, this is a very famous model and also very lightweight, and it's very actually very promising model as in terms of the open source model. So you guys can rely on this model for many use cases. And you guys know the ChatGPT 3.5 Turbo, it's the 2020 GPT model. So I'm inputting the prompt, whatever you do, take care of your shoes. And let's see the text generation here. Okay, so you guys can see the output. I'm a big fan of take care of shoe philosophy. I have a lot of shoes in my life and blah, blah, blah. And let's input the same thing to the GPT model. Okay, so the answer is straightforward. GPT has a lot of context, so it provides you more information. So this is why you have to go with the proper model for your application. Sometimes the more the information model gives serve your purpose. Sometimes you may need a very short answer. But the board models are actually very true. So decide on yourself for your application what suits you. So that's why the model selection is a crucial concern in LLM development. And then let's dive on to prompting templates. Okay. So the prompting templates is provide, like I said, giving more context to the model. So let me remove this part. I already have my Hugging Face key. Okay, so here actually for the template I'm giving, you are an AI assistant, answer the question, and question is inside the curly braces. So actually the ultimate prompt should be like this. So it has the context, like giving some heads up, and then after it includes my question. Okay, you guys can include a lot of things as such. So you guys can include the question and sometimes the examples. So there are some strategies that we can use to do this prompting. So this is why there is a dedicated platform to do the prompt engineering called Prompt Engineering Guide. So here, there are some techniques that you can use. So in this session, I'll show you the prompt chaining, and there are a lot. There are zero-shot prompting, few-shot prompting, chain of thought prompting. There are a lot actually, because these are research outputs more the research going on, more techniques will be here in the future. So better to keep those in your mind, because if you guys are like hoping to do a LLM sort of research for your final year, so you guys can use this as your literature. And if you want to like participate in the competition like IntelliHack, so these things are valuable for you to win the context and the competition. So you guys can try a different prompting strategies and see which strategy provide you the better answer. Okay. So yeah, let's try to run this one. Okay. So here you can see, I'll just show you both LangChain, sorry, the OpenAI model output, and also the open Hugging Face model as same, because I just want to highlight the difference between the open source models and actually the proprietary models like GPT. Okay. Okay. So you can see the LangChain is provide a comprehensive set of tools and services to make LLM application development easier. So it offers a range of pre-built components and modules that can be integrated to application, blah, blah, blah. A lot of information are there. So I'm happy with that. So let me try out the open AI model output as well. Okay. So it provides more information. So up to this level, because in here, I'm using the strategy of chat open AI, the chat prompt template. So here I'm elaborating the context of the human and the system conversation. So first, I'm inputting the system, you are a helpful assistant, and human respond to this question. So this is how the LLMs are trained actually. So that's why we are providing this sort of an context, because it trains for this set of data when they train the model. So if we provide a similar context as such to the LLM, it understood that it needs a chatbot answer. So that's why we provide the templates like human system conversation, like so. So that's why the reason of going with prompt templates. Okay, hope you grab the idea. So we are providing a similar context as they train in the training phase. So they provide you an accurate answer for your prompts. Okay. So okay, so I just highlight you the difference between the Hugging Face model and the OpenAI model to do the model selection. Both models are actually giving you right answers, but which model gives you the most accurate answer, it's up to you, because it depends on the problem. Sometimes the open source model gives you the best answer. But for me, in this case, GPT model is ahead of the game compared to Falcon 7B. And the prompt templates, I just focus few things, and I assist you to go ahead with prompt engineering guide before you implement whatever the application you are hoping to implement. And because it had a lot of information. And this figure, I just snipped from a research paper. So they are tried different templates for the same prompt. So you can see the accuracy of the answer. So for the, let's say the red model, let's consider the red bars for the template 1, 2, 3, 4. So for the template 1, it just give you an accuracy of 75, let's say. But for the template 2, it provides more than 80. So the template is quite important when you do the prompting. So keep that in your mind. It's a design technique you can use when you implement a LLM application. And we just check about LLM chains. LLM chains allows you to include a lot of things, like we can chain a lot of things. So I'll just show you a few things in the later part, in the memory, chat memory and the history part. So yeah, hope you get the idea. Okay, so let's go to the last part, which is the model memory and the context. So you guys have shown that if you start a conversation with ChatGPT, so it knows the context if you use for the same chat for the second time. So let's say I'm from Sri Lanka. I am, let's say, a computer science student. I want to know about AI. And then after, you don't actually need to explain you are from Sri Lanka because it already know you are from Sri Lanka. So you can ask whatever the Sri Lankan specific questions from GPT models. So as such, let's say you want to ask follow-up questions, response iterations, or personalizing your chatbot. So it's very crucial when you are providing a enterprise-based LLM solution. So that's why the memory model comes to the picture, and the context is very important for your LLM development. And we can easily use it from LangChain tools, called as context window. So there are several techniques. There are actually three. So one is chat message history. So basically you are providing a full message history for your LLM model. And then the conversation buffer memory. You are not just providing the full history, but just buffer the story. And conversation summary, you are just providing a summary memory for your chat model. Okay, so let's jump off to the, because these things are very straightforward things, but that's why I just go in a very quickly, because you can grab the idea, because not just, it's very straightforward. That's the way they implement those techniques is by looking at the way human answer the questions in a normal conversation. So let's see this in action. So yeah, you need several packages for demonstration purposes. You can see the packages that I have installed, but same set of examples are available in LangChain. So you just have to like go to the LangChain and just search about memory. Okay, so it will provide you a lot of information inside the memory of components in the LLM, sorry, in LangChain. Let me show you one. Conversation buffer memory. Yeah, here we go. Okay, so here we can find the memory part, and here you can see how LangChain is supported to do the memory context saving of a chatbot. And here you can see the demonstrations, and a lot of information are there. So it's a very versatile documentation. You guys can get whatever the information you want from the LangChain documentation. Okay, without further ado, let's try out the full history part. Full history means we are providing the exact context for the model without diluting it. So for an example, I'm giving an instance of chat message history, and then I ask, hello, ask me anything about Python programming. And then after, I'm asking a Python specific problem. So it's very easy for me to the token size is a critical concern for LLMs, because if we exceed, because there is a limit that we can provide to the LLM. So we can mitigate that by using this sort of memory models. So it knows the context, and we can ask whatever the follow-up questions from the LLM. So then after, we are asking what is the list comprehension, and then describe the same in few words. So this is a summarization, right? So we are asking a generic question, and then a specific question, and then a summarization. It's kind of unchained tasks. So let me run that. So, okay, for the second print, I could see the less comprehension is a concise way of, so bunch of details about the Python lists. And then I could see the summarization version of the list comprehension. So that's how you can provide the full history for the model. But actually, if you guys think in a logical way, it may not be the actual design that we can go for, because there is a limit that we can provide, because memory itself can have some limits. So it's not the ideal way of structuring for many applications. So we have to buffer a few things, right? So buffer in the sense, we are including the context and follow-ups in a single prompt and then expect a single answer. Okay. So it's not just like input, output, and output go to the input. Likewise, we are just like giving more context by providing sub steps. Okay, I'll show you one. So here I am using, for that purposes, we can use the buffer memory, conversation buffer memory, and I'm using OpenAI model for that. And here I hope I didn't expect this question, but I expect this question from you guys. The temperature part, I forgot to mention that. The temperature is the randomness of the model. Temperature we are usually allowing to 0. If we increase it, the randomness it's going to high, because it increase the hallucination. So it will give you some creative outputs, which is not relatively similar to the training set. Okay. So then we are creating a conversation buffer memory with a size of 4. So this is the buffer size you are inputting the model. So you can define whatever the buffer size you want, let's say 10. So you can buffer 10 prompts before you get the answer. And then we can chain it using LLM, LangChain. This is a very famous function in LangChain. And then we are asking the questions one by one. So let's say write a Python code to draw a scatter plot. Use the Seaborn library. So then after we can put another buffer. So let's see buffer chain dot predict input. Name the scales. Okay. So I'm just providing a specific context. So you can see it's starting from here. And then, so this is the first prompt, the write Python code to draw a scatter plot. This is that part. The chain is finished. And then it goes to the second part, which we assist the LLM to use the Seaborn. And then we assist him to name the scales. And then after we got the answer, the scales used to scatter plot are typically x-axis and y-axis. The scales are represent the ranges of values and a lot of other information. So that's how you like summarize the information. Okay. So if you ask the same question from LLM, so it will give you a lot of information which is not relative for you at all. So this is how you can improve the LLM output by using memory models for this sort of GPT models. And conversation summary models, this is another optimized version of the previous buffer version. So we can like ask the difference between the buffer and the summary means, in the buffer, like we are keeping the same set of buffer for the next input. But in summary, it inputs the prompt and get the summary version of it and then input to the next version. Okay, that's the difference between two models. So let's see the accuracy of this conversation model. And then, yeah. Okay. But it seems to be like I just tried this conversation summary memory quite a lot compared to buffer model. This is the ideal way of structuring if you are going with chatbot sort of architecture. So it will give you a lot of accurate answers, especially for the customer context. When people are asking very random questions, it answers very accurately. So this is the same way, like these. First, you have to import the model and then import the instances of memory model. And then you just have to provide the conversation chain instance, and then you have to just chain everything as a summary for the model. Okay, so yeah, I hope you guys grab the concept of the buffer memory and the conversation summary memory and the full history. So full history is you are providing the exact same prompt output, and the buffer means you are just stacking up few things and get the output. The summary version means you are just providing a summary and for the same buffer memory. Okay. So this is how I like deep dive to the ways that we can use to the techniques. So as I said, the main reason to use memory models, the context window or the token size is a critical concern, because there is a limit that, because for the GPT 3.5 it's 1024 characters or token size. I can see GPT 3.5 token size. Yeah, it's 496 tokens. So actually there is some padding. So it's actually 3,896. So for the GPT-4, it's a lot. So this is 128K actually. It's more than that. Okay. So yeah, that's the plan, and I just covered everything that I planned for the session. And then just I want just highlight the few things that are remaining. So maybe you guys can look up to those sections. So to like for the full coverage of learning LLM development. So the retrieval augmented generation, the RAG implementation, and then LLM agents and troubleshooting and evaluation. So that's why it's very hard to cover up everything in a single session. So I just look into prompt strategies and the memory models and actually the aspects of model selection. So the Hugging Face and LangChain quite famous these days to do the LLMs, and especially for the LLMs also. The operation part is very quite easy with LangChain. So if you guys are enthusiastic in LLM research directions, I'll just provide you some insights about what are the possible research areas nowadays with LLMs. So the hallucination is a very hard thing to measure these days. Like there are no like straightforward methods to measure hallucination, like a quantitative measure. So like people are come up with different strategies to measure it. And then optimize the token size. I just explained the token size of GPT. So it's very less. So if you input a PDF and just try to get the outputs, it's not possible, because if your PDF has a lot of text, the model will output as the token size exceeds. So in that sort of sense, you have to come up with token size limitation methods like the summarization. There are some ways like you can use, like there is another way called compression and chunking. So you have to go with those techniques and make agents usable. So I just explained you the Devin. So Devin uses a lot of agents. So agents themselves should have communicate with each other, right? So provide you a better answer. So the communication between agents, it has to be optimized. So to make it usable. So the other thing is to incorporate other data modalities. So for a lot of things, we are just using text models. So what about time series? What about images? What about videos? So we have to just improve LLMs for those phenomena. And we have to enhance safety and security. So let's say if we ask from LLM how to do a suicide, so LLM shouldn't give a response, because there are some ethical concerns the model should respond. Because if you make your model publicly available, so those things should be adhered. So it should be like provide you sensitive content and security context. So let's say your model is trained with very personal information, so it shouldn't output as a result. So the OpenAI model, they are on top of the LLMs, they are writing a lot of scripts to avoid those things. So you might have seen a lot of memes and discussions going on with this area, like the pirated content, how to get pirated content from ChatGPT. So there are a lot of things to improve. So the current state is not the final state that we are expecting from an LLM. There are a lot of ways to improve. And of course, the downsides of LLMs. So sometimes people using it for like for the not for real purposes. So sometimes they are just using for do nonsense. So it's a compute wastage. So sometimes if you're not using technology for the right purpose, it's a wastage, of course. So because for running LLMs, you need a lot of compute resources and power. So that drawback is still there. The same goes with blockchains in the same day. So because for the cryptocurrency to run in the blockchain, you need a lot of compute resources. So same goes with LLMs. And proper evaluation is problematic still. I believe it's unsolvable until we are getting a lot of good compute power to do our LLM computations. So these drawbacks are there, but the good side is quite a lot compared to the downside. So still, that's why the LLM is kind of the pinnacle of AI technology. So it's our responsibility to use the technology for the right purpose. But at the same time, we should know about the downsides as well. And with that, I just want to conclude the session. And I believe you learned something. And hope you guys carry out today's learning for your future applications, of course, for the IntelliHack competition, and also for your day-to-day learning purposes and for your research, for your projects, for your other things. And I believe these learnings will help you to carry out those tasks quite easily. And just a phrase from my end for you guys. So this is very famous quote. So if you know what it is, you are a student. So now you are a student. It's not enough. So in future, you need to know what it is and how it is. Technician, don't stop at that level. Just know about what it is, how it is, and why it is. That's the way you have to be as a computer science student. So you are an engineer and you are a researcher. So yeah, explore the new arenas of computer science and technology, and at the same way know about know what, why, and how. Because I saw many instances students are using LLMs without knowing the ground level knowledge, and they are just blindly using ChatGPT for their applications. So it's not the right way. So learn about the foundational concepts and then use the technology. Okay. So if you have any questions, just don't hesitate to ask from me now. And I'm available in social media, so you guys can ask any question from me. Thank you, and have a good evening.
Thank you, Mr. Dissanayaka, for that insightful session on developing LLM applications with LangChain and Hugging Face. Now it's time to dive into our Q&A session. Let's make this interactive and casual. So if you guys have any questions, don't hesitate to drop them in the Padlet provided. So while y'all are at it, we already have a couple of questions in the Padlet. I'll read it out. So the first question is about LLM hallucination. So the question, what is the best approach to reduce hallucination? Is there any implementation that can completely remove LLM hallucination?
Yeah, it's a great question. So unfortunately, it's we can't avoid it 100%. So, but we can do a lot of fine tuning. So it make like for a up to some extent we can avoid hallucination. I mean, good 95% we can avoid hallucination. First technique is the prompting strategies. So I just mentioned about the prompt chaining today. So this is like you are providing more and more context and the ways that LLM to think about the problem, because LLM is trained with a lot of data and it can think in a lot of ways for your question. So what we had to do in the fine-tuning phase is to filter out your response as you want. So that's why the context is very important. So when you do the prompting, provide more context that you can avoid hallucination, and you can provide a lot of things, examples and example prompts, questions, and other things, the formattings. So that's why I just suggest you the prompt engineering guide. That's why you can avoid hallucination in to a great extent. So just have a look on that guide and know about things that we can use to avoid hallucination. Yeah.
All right. So moving on to the next question. It reads, is it better to select a general LLM with parameters 70 bytes to 500 bytes, or an LLM with far fewer parameters, like 7 bytes, with some domain specifications?
Okay, if I understood your problem, as I said, the model selection is a domain specific thing. So even though it has a lot of training parameters, yeah, I could see the numbers. Generally, a little bit parameters. Okay. Yeah, so parameters means it has a lot of knowledge, right? So that's why the GPT model will give you a lot of lengthy answers for your prompts. So that's why the difference between the Hugging Face model that we just explored. So it's a 7 billion model. So it just give you a short answer, but it can be relevant. But if you use a large architecture like GPT-4, it will give you a lot of information. But for your problem, if you need more information, just go with a large model. But it requires a lot of processing, and in most cases the processing part is done for you. You are just importing the models from somebody else. So but you have to do a lot of fine tuning. That's the downside. So just you have to trade off with the use case, but generally it's better to go with a large model. If you go with a small model, it will not give you a proper answer, because for most cases you need a lot of information from in terms of a chatbot or some sort of an Gen AI architecture. You need information, right? Yeah, but it depends. That's my advice for you.
Cool. So the next one is about Google Gemma models. What is your opinion on Google's new Gemma models and their performances compared to other open source models?
Yeah, it's an amazing model because the companies like Google can only do that sort of an implementation, because Google has a lot of information, access to a lot of information like Google Search, Google Image, and none other tech companies can implement that sort of a model. So it's a great innovation. And also they want to stay in the competition. That's why they came up with Gemini. And my opinion is lot into positive side with Gemini, but multimodality is kind of very problematic. Like in the context, like in the chatbots, I don't see like users need text, image, and audio at the same time as a user. So I see some downside with the application. So where we can actually apply Gemini model. So, but seems like a great invention. So that's the downside. So that's my opinion. So in terms of data, I don't have any concern. It trains with a lot of data. And of course, it's Google, so you can faith on Google's models every time. but the application part is some questionable. So yeah. Okay, and let's go to the next question, LLM hallucination. I hope I answered that question. And next one, the research related to AI and other disciplines. Yeah. What areas can students explore for research that combine AI with other fields for yeah, of course. So the human-centered AI is uh, going to be a very important area for AI and related disciplines, because now the people know what is the capability of AI and what it can do actually. Many areas like for aviation, and aviation in the sense the traveling part, the travel, and so a lot of applications are there. For all them, we have AI related applications, but the explainability part is the most hardest part in the moment of speaking. So the explainability part will be the next focal point of AI. So you have to think about how we can explain the neural networks, how the predictions are happening. So that part is a quite interesting part. And of course, there are, so up to this level, up to transformers, all of the neural networks have been implemented through propagation algorithm, as you all know. So this is proposed by Geoffrey Hinton, one of the godfathers of AI. But then after, the ways we are thinking about neural networks should have changed if we want to implement more and more performance and optimized models. So the back propagation algorithm is come to its pinnacle. So, and it come to its most actually for the top most point in transformers. There can be other architectures implemented by that propagation, but there are other ways that we can implement neural networks. So one is very recently I shared one paper in LinkedIn, which is actually, yeah, the way they are analyzing the neural networks are using functions, entirely a new function. So we call it TANG. Okay, so there are a lot of other ways the research are ongoing, and I think I mentioned few in my slides also. So we have to expand the LLM capabilities to other data modalities, and the evaluation part is quite problematic these days. So there are few ventures that we have to give solutions for LLMs. And of course, there are a lot of room for the improvements. We just have to explore the right areas. So yeah, in terms of examples, I can provide you a lot. So, but I'll suggest you to like read a few documentations and recent research papers to, if you want some specific examples. I can give you some examples in the area of time series. So in the time series these days, like we are like finding ways how we can integrate LLMs to do time series analysis, which is very hard, but we are just want to like get the capability of LLMs, the possibility of getting the LLM capability. Okay, for the last question, the Pinecone and OpenAI storage. Okay, it's a nice question. So Pinecone is a vector storage, of course. Yeah. For the vector databases, because recently we had a competition in our company, so the Pinecone was a very, very useful tool for that, because it allows you to store a lot of information. As I said, the token size limitation is quite a concern for LLM. So using Pinecone, we can store the information using vectors. And so Pinecone allows you to store your prompts as vectors, and you can store your data as vectors. So it's very easy for you to do the fine tuning. So that's the advantage of Pinecone. And OpenAI storage, I'm not much aware of it, but compared to OpenAI storage, Pinecone is the best way to move if you have a lot of fine tune to do. Like if you have a lot of, let's say you are like implementing a code generation tool for ML development. So let's say you are implementing an agent to do ML development using an LLM. So you have to provide more and more examples, right? So sample codes, and so in that sort of a sense, Pinecone is the best way to move. Yeah.
Right. So that seems like all the questions that we have got. So um, I'll give everyone like another minute. If you all have any other questions, y'all can drop it in the Padlet. And while y'all are at it, we would greatly appreciate your feedback on this session as well. So please take a moment to share your thoughts on the feedback form provided. We'll provide it in the chat box. Yeah, it's already there on the chat box. So yeah. Okay. Seems like that's all the questions that we have. So yeah, moving forward on today's agenda,